So welcome. If you're almost through Devnexus, and that's got to feel good. Lots of good content here. This is one of my favorite conferences to be at. How's my volume? Am I good? Usually that's not a problem. All right. So you're in configuring Apache Camel for the cloud. And before I get started on this talk, I'd like to get an idea of the folks here, just their general experience. How many people are using the cloud right now? Pretty much everybody, right? How many folks, when they're in the cloud, are mostly using VMs to deploy their code to? VMs? Okay, yeah, that's still the most. What about Docker? Okay, a lot of folks Docker and VMs sometimes. What about some orchestration tool like a Kubernetes of some type? Okay, good amount of hands go up here. So how many people are not familiar at all with Camel? Okay, so we've got a few folks that aren't familiar with Camel. That's fine. We're going to cover a little bit of Camel, but the biggest part of this talk is talking kind of about the soup to nuts of all the different types of cloud deployments you can have and how Apache Camel can fit into those different types of cloud environments you have. So whether you're running on VMs, running on Kubernetes, my hope is that you're going to get something out of this talk to bring back to work with it on your teams. Whether you're evaluating Camel, using Camel, and just looking for a better way. So just real quick about myself. My name is Bob Paulin. I'm an independent consultant out of Chicago. I do work throughout the Midwest and in Chicago for mostly JVM technologies. That's my Twitter up here. Some of the code examples that you'll see, I will tweet that out later. So folks that are looking to dabble in some of the code, it will be available. I am very big in Apache Software Foundation. I love the ASF. I'm an ASF member. I'm a contributor to Camel. I'm not a committer or PMC on Camel. I'm a PMC member of Apache Tika and Apache Felix, which is an OSGI framework. I'm a committer on that. So those are two of my projects, and Tika, I contributed the Tika plugin to Camel, so if that doesn't work, we can have a conversation after this if there's anything that needs fixing. I'm a Java champion, and I run two podcasts with a couple other folks. Did anybody go to the Pubhouse episode, or the Off-Heap episode last night? No? Okay, well, we recorded an episode. It's all about Java news, Off-Heap. And then Pubhouse is kind of like this, like more of the technical track of that, talking through a technology, how to implement it, all of those things. So excited to be here. If you are enjoying the weather recently, I am from Chicago, as I mentioned, so you have me to thank. I brought it with me. I may or may not bring it home when I leave tomorrow. But if you are enjoying this weather, there is a conference in Chicago that I'm going to be involved with later this year, jconf.dev. So it's Chicago, so it may be 90 or it may be snowing in late September. I can't really predict, but if you can get through this, you'll be just fine. I do, yes. Are we good? All right, moving on. So Camel in the cloud. So I've already kind of done the survey. So what is Apache Camel? For the folks that are not familiar with Apache Camel, it is an integration framework. So the way I like to describe it, it's glue. It's glue that ties other pieces of applications together. It converts protocols one to another. It can convert your SOAP services into REST services. And it does it through a DSL that's very consistent. So no matter what kind of dependencies you're bringing in, using Camel with that dependency is going to make the look and feel, the programming experience very similar, whether you're going from a message queue to a REST service to gRPC. It all looks the same. And we'll see that when we get into the code examples. Now, Camel integrates to a lot of stuff. And this slide is not up here for you to read it, but just to try to fit in all the different components that Camel integrates to. If you are using a popular library and it connects to something, there is probably a Camel component for it. And if there is not, it is actually a very straightforward framework to implement new connectors to consumers and producers. And the community is fairly welcoming. That they take pull requests from me, so they'll take them from anyone. Definitely check out the component list. There's I think 300 components on that list. So let's talk a little bit about the cloud. So as I was mentioning before, a lot of different variations of how people are putting things in the cloud. We have Docker, we have AWS, we have Azure, we have Kubernetes running on all of those services. There's lots of different things in the cloud that we don't run into, though, if we're converting from on-prem. So when we go into the cloud, we kind of give up on a lot of our guarantees, right? We may or may not have SSH access. Once you get out and it's Kubernetes as a service, we might not be SSHing into those things. We may not have control of the hosts. Network IPs are going to change on us fairly consistently. So we're going to need something that's fairly dynamic to be able to deal with an environment itself that's extremely dynamic. And that's why I think mixing Apache Camel with the cloud is kind of a marriage made in heaven, because Camel is a very dynamic framework. It can integrate to anything. You may not know what you're going to be integrating to when you're going into the cloud. New services are always coming up. So as those things come up, they become popular. The Camel community is going to add a component for that. Camel being a DSL for integration, the cloud is on-demand application provisioning. So whatever you can spin up, I can connect to. Recently, in the 3.0 release, and I don't know if folks have been following some of the release schedule, the 3.0 was very recently released. They're looking to cut 3.1 very, very soon if you're watching the boards. They've modularized Camel even more so that you really only have to pull in the things that you need for the framework rather than having to maybe download the internet for everything. Which is a common problem with Apache Camel. With the cloud, you have various deployment runtimes. So you could be running it in a Kubernetes as a function, in a small Docker container. You could be running it on a VM where you have all of the CPUs at your disposal. So depending on what you're doing, you may want to pick a different deployment model. Camel can scale to those different deployment models. Supporting all the different protocols and data formats. Again, Camel is a good way of converting data from one thing to another because they already have a lot of these things built in if you're transferring protocols back and forth. All right, so when I asked the question to begin with, how many people are running virtual machines in the cloud, that I think had the very most hands. So not a big surprise. Virtual machines are still very, very popular running in the clouds. You go to enough of these talks and you just figure, everybody's on Kubernetes now, right? Not the case in reality. I'm a consultant, so a lot of my work is still very hands-on with my clients. I'm not selling products. So you see VMs are still the familiar things that operations folks know, that developers know. So they are still the main thing that I'm seeing with clients. You have a lot of control with VMs. You have the entire machine to yourself a lot of the time. You're going to have persistent local storage. It's not something that's just going to disappear when it crashes. That can happen, but most of the time the storage is going to be persistent. But because of some of the reasons we go to the cloud, because we want to be able to scale, because we want to be able to grow and scale up our applications, there's some things that are not in VMs that we have to build for. Some of those things are like discovery. We're trying to discover applications within our cloud environment. We also have to maintain the VMs. We have to patch them. We have to worry about security vulnerabilities. We also have to worry about things like fault tolerance. If the VM goes down, if network connectivity is lost, VMs are not like some of these newer frameworks that have things built in to deal with fault tolerance automatically. So we have to work around some of those weaknesses. Now, fortunately, Camel can allow us to work around some of these weaknesses. Camel has a registration and discovery service that can be used with REST services, TCP services, gRCP services, where I can be just deploying the stuff to VMs, and it will go find the services that get registered by the producers. So let's just talk through a visual example because some folks may not be familiar with how this works. There's two basic frameworks that help Camel facilitate this out of the box that have both registration and discovery side. There are additional discovery side components where if something else is registering DNS, Camel can discover through like a service record in DNS. But if you're looking to try to do it on both ends, where this is Camel and this is Camel, and they want to talk to each other. Zookeeper and Council are the two frameworks that work in the current Camel release. So let's say I have two services. One may be Camel, one maybe not. In this case, let's assume they're both. One has a service that I'm trying to call, and the other one is a service that is consuming that service that may or may not know where that other service is. And then I have an instance of Council running in the background. So when I start up the service that's going to be producing the data that I'm looking for, what that service will do is it will take the host name and the port that it's running on and post that up to Council, along with the URI so that it can check to make sure that that service is up. The second thing that can happen, so that now Council is aware that this service exists. The second thing that happens is when the consumer is trying to call that service, it's actually not going to call it directly because it doesn't know where it is. Instead, it's going to call Council and ask, where is my service? So that service is going to have a specific name. Council is then going to reply with one of the local the host and port numbers that service lives on, one of the healthy instances. So now the consumer has the address and port of that service. It can now call that service without having known where it was to begin with. So this is just your typical service discovery example. So if you have a question, when you think of it is the time to ask it, but because I'm going to be just kind of bouncing around through a couple of things. So here what I'm going to do is I've got an instance of Karaf running with Apache Camel. So this instance has the calling function. And what I'm going to start is a small Spring Boot application, actually I have it already running, that has the service discovery. So if I curl the consumer, so I call service call on the consumer, I get path 1, path 2. So how is this working? So it's gonna bounce between the paths, and these are two services running on two different ports. So let's look at some code. So within the service example, again, this is just a small Spring Boot application. Can everybody read that, or do I need to make it bigger? Oop, that's not going to help. A little bigger? All right. I'm declaring it as a service, and then I'm providing, so here it's basically these two lines. I'm declaring a service, my service, and then I'm declaring what's actually serving up the content. So in this example, it's the Undertow application server that's serving it up, that's running within Camel. It's going to be served over HTTP, and what you have over here is it's just going to find a random available port. So these ports are just spinning up. I don't know which port it's going to be on in advance, which is why this example can be just like anything in our cloud environment where we don't know where the service is going to run. Then it's going to produce our text and which path that I hit. So there's two ports that this is running on. Now, if I want to look at the consumer side of this, I can go into the REST service call, consumer, and here's my service call route builder. So here I'm just using the Camel REST DSL to register a path / service call, and that's calling a direct route under service call, and what that is going to do is it's going to call service call, the name of the service, and then I tell it that I'm using Council for service discovery. Now, if I have to configure, where Council is, it does need to know where Council is before it can make this call. But after that, it's just able to find the other services through service registration. So this makes sense, right? So this is one way we can work around not having a Kubernetes, for example, to tell us where things are through DNS or through their APIs. All right, so the second problem was dealing with fault tolerance. If you're not working with an orchestration tool, Camel has some of this stuff built in. So it has two circuit breaker type technologies in Camel. It's got Hystrix and Resilience for J. The Resilience for J service is a little bit newer. I wouldn't say they're completely drop-in replacements because Resistance for J is a little different than Apache Camel or than Hystrix. But the Hysterex support has been around for a couple releases now, and it can help deal with fault tolerance in your application. Who's heard of Hysterex? Okay, so circuit breaking basically is the idea is if you get enough failures, something can be taken out. You can go to a fallback, and then if that recovers after a period of time, it'll start making that service call again. So if you have a cluster of applications, one thing that can happen is you have it where the applications, some of the circuits are open, some of them are closed when you're having in a failure event. So what I have here is I've got a couple of different routes in the next demo that kind of show some of the circuit breaking functionality in Camel. So here, I've got 3 different circuit breakers configured. I have a threshold error of 20%. I'm having the metrics, the window being about 10 seconds, so that's why it's going to take its interval of if there's so many failures within that window, it's going to do the fallback. And then if the load balanced route fails, you're going to get a fallback message. I have that going to a route where there's 2 different APIs. There's a slow one and a fast one. You can also set an execution timeout with Hysterex, which is kind of useful. Most of us are very familiar with setting read timeouts, where if packets stop coming in, we time out, and we set those for a second. We're like, okay, if the call takes over a second, then it's going to time out, right? Not really the case, because as long as data is coming in, that read timeout may make that call still take longer than that read timeout. With an execution timeout, which is the way Hysterex does it, there's a separate thread that spins up to monitor the time. So I can say, if this call goes over this much time, then we're also going to fall back rather than determining, hey, are the packets still coming in? So just to get a sense of what this may look like, I have a small JMeter script written that's going to hit our circuit breaker routes. And what can happen if you hit the slow route, which is going to hit 50% of the time. Oh, that's really, can anybody read that? So, I mean, what we're seeing is about 900 milliseconds to 600 milliseconds average time. The slow route has a 2-second delay on it, where the fast route is 100 milliseconds. But what we see is sometimes when we're using Hysterex, we end up sending, we continue to send requests to it even though we know there's a problem. So one of the things that I've frequently built around Hysterex when I've run into this problem where it's like, you know, I want to sleep at night. So if this thing's going to be constantly down because maybe something's run out of memory and it's slow, I actually want to kill that feature. A lot of the things I do in the cloud, I end up feature toggling. And it's nice when you can have an open circuit, also turn off your feature toggle. So rather than just having where the circuits can be open and closed, I'll also throw a feature toggle in console where once it springs open, I can have one of the instances actually just turn the feature off. So the impact of that, well, let's look at some code first. So with the circuit breaker, so with the kill switch, I'm also going to read in some exchange property. Well, let's actually go back to how the exchange property gets created. So within Camel, I can create interceptors that wrap different types of routes. So here's an interceptor that routes every REST call that comes in. And by doing this, I can inject some feature toggles in as exchange properties, and those exchange properties are available to any calls on that exchange. So I can set this feature toggle's true, this feature toggle's false, based on a call to console that I'm caching in Hazelcast just for speed, and then pass it along. So if I hit my toggle route, I have each one of those Hysterex wrapped in a feature toggle, so I can actually turn the entire route off if there's too many failures triggered by the circuit breaker. So if we go back to the kill switch, I'm looking for that short circuit header. So if I get a response that's a short circuit, and that's true, I can trigger the kill switch, which flips the feature off, essentially. So if I stop my test, which I did, Let's flip the route from the circuit breaker route to the toggle route. Save. What we'll see is it'll start to fail, and then we'll see that it gets flipped off for every single one of those routes. So our average response time stays low, our error count goes down because we've turned the bad feature off. Very simple thing to do in Camel with just a little bit of code. And again, this example code will be available. I'm not going to go through every single line of it during this talk. Any questions on that? Global circuit breaking versus local circuit breaking? Because I think that's a concept that once you get a circuit breaker, you're like, hey, we've solved the problem. But in some ways, it's not the last solution that you end up with. Okay. So let's talk a little bit about deployment. So these are all functional things that work within our apps with Camel. But there's also some pragmatic things about putting Camel on a VM. And the first thing is those of you that raised your hand to do Camel, some of you are kind of grudgingly maybe about it because some of you may not even like Camel very much because Camel has a lot of dependencies that we showed on that first slide. So it is very easy to create a Camel application with a bunch of integrations that gets you in jar hell, where you have so many dependencies coming in, you're downloading the internet, you have conflicting versions, and things can break. So this is one of the reasons why when I deploy Camel, and especially if it's going to be more of a monolithic type application, it's very useful to put it in an OSGI container like Karaf. So Karaf is another open source Apache project. It has Camel as a feature, and they've already done the work. There are people that do not like OSGI because of the complexity. They've taken all the hard work out of breaking Camel up, doing all of the management of what can talk to what, and the class loader, what's exposed and what's not exposed for you. So you just end up writing Camel code and deploying bundles. It also comes with kind of a slick CLI, SSH access. It's got monitoring built in. It's a full-fledged container for running your Camel project. So if there's going to be something that's going to grow, and you're not going to be breaking it down into microservices, Karaf is a good way to get started. And even if you do break it into microservices later, you can take those bundles and turn them into standalones. If you look, again, in the coding examples that I have, each one of the Karaf bundles that I'm running in here, I have some extra classes in there. So if you want to run it as a standalone, you can actually take it out of the Karaf container and run it that way as well. So it gives you kind of a transition. Yes? Service Mix comes with it. It's all already built together. The reason I mentioned Karaf over Service Mix recently is I think Karaf gets a little bit more love from its community than Service Mix. Service Mix, it has an older version of Karaf. I've found to keep up with the newer versions of Camel because the Camel iterations are fairly quick. Sticking with Karaf allows me to pick them up a little faster. That's my opinion. Some other people may have other opinions and may like Service Mix, but it's there. It's a very old version of Camel on Service Mix right now, and Klaus is very big on 3.0 if you've seen any of his recent talks. So yes. Okay, so when do you use Karaf? So we've been through some of this already. So if your project is going to use several components and you need them in the same process, maybe for performance reasons, maybe because just the developers aren't ready for microservices yet, they haven't figured out HTTP, and Camel or Karaf is a good way to allow you to deploy a large amount of Camel code together and have it work safely. If you're looking to add features dynamically, this is kind of one of those things with OSGI. OSGI does allow you to deploy to it while it's running. I've gotten away from a lot of that, but there are instances where I've seen folks that do want to deploy with the app container still running. There was a presentation actually at ApacheCon on some folks from Netflix that are deploying to Karaf directly, and they are taking advantage of a lot of the dynamics of the OSGI container. So this allows you to actually add a component and new code on the fly. The other really nice and kind of undervalued thing is there is a CLI to this. So if you're trying to take heap dumps, if you're trying to view how many routes there are on the Camel exchange or on the Camel context, Karaf already has a CLI built in to start, stop routes, turn them on and off, to view performance metrics on the routes. So all of this is already built in for you. So if you're trying to measure things and you're comfortable working with the CLI, it has it. It also has some connections into like Prometheus to push data there if you're trying to do that too. So when working with Karaf, there's two different ways that you can use it to deploy Camel code. The first one is just a build time distribution where you can just build a zip file. And the second way is Cellar, which is a clustering solution. So in the distribution way, there's a Karaf Maven plugin that basically builds a zip file for you. So just to give a look at what that looks like. So if I'm going to build a Karaf instance, I'm going to name so this is actually even a static framework. So there's a static and a dynamic framework. If you want immutability, you can use the static framework in Karaf, and then all the configuration and all of the dynamic loading is kind of taken out. So if you want immutable deploys where nothing is going to change and everything is already there, look into that static framework. Then I just define all the features I want. So the provision static, that's where I put all my Camel stuff. So here I'm just listing out features at the Camel version I'm running off of, and I'm putting in a few different jar files to run. All my client ones I've got here at the bottom with my custom code. And what I end up with is a zip file or a tarball. So if I'm going to eventually package the thing in Docker, it's actually quite simple for me to do that. Docker will automatically unzip a tarball. So I can just define, hey, this is my distribution. These are the ports I'm going to open if I want web management. Or 8880 is just where I'm running HTTP off of. And then I can run with a simple Karaf script. The pros of using the distribution, especially like the static distribution, is it's predictable. You just have to know Maven. You don't need to have crazy DevOps skills to deploy a container. You just unzip it and you run it. And it gives you an easy way to go to Docker. Now, Cellar is a clustering technology. So with Cellar, it uses Hazelcast for discovery. So you can have multiple versions multiple instances of Karaf running that talk to one another that you can provision through a single instance. So the way this works is if you have them configured to be clustered, you can add a repository to the cluster and then just install the Camel feature to the entire cluster, and then the entire cluster has all the Camel jars and runtimes. You can also do this with your client code to make that work. Now, the benefits of Cellar is if you are actually going to do those dynamic deploys while the engine is running, this gives you a way to do it to all the instances at the same time if you do not want immutability. And it also has it where the logging and the eventing, so if you're using the OSGI event admin, all of those instances are going to be able to talk to one another through events. So if you're looking to do messaging and you don't want to do that distributed, the framework offers a way to do that. All right. So what about Docker and microservices? So by far the most hands for Docker went up when I was talking through that. So there's a couple other deployment options you can use with Docker and microservices because you may not want that full container. Docker is already going to give you sort of an immutable image to start working with out of the box. So I may not need to worry about a static framework and another container if I'm going to deploy into Docker. I get isolation, so my CPU, my networking, all of that's going to be contained to the Docker container, and I can version my deployments, which is a huge benefit over just deploying a zip file to a VM. Weaknesses, unless you're going to do like an overlay network where all of your Docker hosts can talk to one another, you still have to do the discovery piece. It's very limited. And you still have, with it being isolated, you have less control over the container. You can do whatever you want in your Docker image, and then that's it. So for deploying in Docker, I found using Spring Boot or the standalone Camel, just Camel by itself has been very effective. So when do you use each? So Spring Boot has the Spring Cloud. So that discovery stuff I showed before, it makes it even simpler than what we would have to do in the code otherwise with the OSGI framework. Camel has starters that manage the context for you, so you don't actually write, get me a new Camel context. They manage all that. They manage the registration, the routes, all of that. So you're just adding component tags like you normally would in Camel. And then you also get the goodness of some of the Spring Actuator for health checking and some of the other things that you're going to want to do in your Docker container. So for the Spring Boot starters, you're adding some of the dependency POMs into it, so the Spring BOM, and then there's a separate Camel BOM that has all the Camel features that you would pull into your POM to make your project now a Spring Boot Camel project. After that, you add the starter components, which are, so each one of the Camel components, almost each one of the Camel components has its own starter. So you can bring in just the Camel components that you want. And then after that, you're just adding your normal Spring component tag to the route builder. You can use any of the dependency injection that's already there in Spring. You can use the value tags to bring in configuration. All of the goodness of the Spring ecosystem is now at your fingertips. The other thing you get is they have Spring Cloud Discovery. There's been a lot of effort within the Camel community to make it more Spring Boot friendly, and this is one of the major things. So we already looked at this code, but what I didn't show you was the console configuration. So I did say, hey, you do have to find console, you do have to define a few configurations. All I'm doing in my applications properties to make it console aware is I'm enabling it for console, I'm enabling discovery, and then I'm telling it which host it is. Because in a Docker deployment, often the IP and the host that you see in the Docker container is not the one that you actually want to tell the other containers about if you're not doing an overlay network. Let's say I installed Docker in this host, Docker in this host, but I'm still connecting through the host names of the individual VMs. I'm just registering ports. I may want to change that from what's being registered on the Docker network. So I can do that through the cloud config. The other thing I don't have to do, because I already defined console as my discovery mechanism in the Spring config, I had the console thing in the route itself. I don't have to do that here. I just make a service call to my service, and it does the discovery through the Spring Boot application. It's already configured to work. All right. The other thing we get is some of the actuator data that's available for Camel. So within actuator, I'm going to get the version of Camel that's running, the uptime that it's running. I'm going to have an actuator with all the Camel routes that are running. So if I'm wondering what is running on this application instance, I can just hit an HTTP call and it's going to list out. Oh, there's a question.
Yeah, on this actuator, I think a lot of times it depends on when you have a Spring MVC framework there. What if you're just listening to a topic or a conflict?
Yeah, so you do, obviously to do it through here, you do need a HTTP port exposed that you can hit for your actuator to work. I don't know if it's, because the actuator, I think, has its own starter, I believe.
But I think it's dependent upon you having.
You obviously need a web container and a HTTP port. 100% agree. So you do need that. So if you're just doing messaging, okay, yes, I'm bringing an application servlet container. Is that your point? Just to do messaging? Because I mean, that's the one thing I also find kind of awkward about doing some of the Camel stuff in Spring Boot. It's like, well, all right, I just spun up Tomcat, but I'm just doing pub sub over ActiveMQ. But getting health checking and things like that can be an added bonus if you're willing to take a few more dependencies. Limitations. If you like the refresh scope, because you like Spring to be dynamic and you like to be able to refresh your config, it does not work very well with the Camel component still. It will not refresh the Camel context. So if you make route changes that influence the context, those don't get refreshed when you hit your refresh config endpoint. So really, if you want the dynamic stuff, you want to go Karaf. If you don't want dynamic and you want static, immutable, and you're doing Docker, the Spring Boot can be very useful. So again, when to use it, integrating with other Spring infrastructure. If you've got Spring Cloud config, you've got other Spring things in your ecosystem, your developers know it, makes it very, very simple. You want to use service discovery and you want it to be very low configuration. And you're using the supported components. Like I said, there's Most of the key core components are configured as Spring starters, but I don't know that all of them are supported. All right, so let's talk about standalone. So you don't actually need an application container to run Camel. I can just run Camel by packaging the jars together that would normally be dependencies. Now, when you compare like sizing, if density is something that's important to you, if you just do some standalone Camel, this is just one with like, hey, an HTTP endpoint and just the Camel core, you can get around 10 megs for your Camel jar if you're just packaging that by itself. If you're going to use Spring Boot or Karaf, it gets much bigger. Yes?
Are you talking about, are these numbers from Camel release 3?
Yeah, these are for 3.
Okay.
That's right. Mm-hmm.
So there's a lot of talk of using Quarkus and Paulin. Is this optimized, or are you getting it?
So I'm not going to get to core because there are a bunch of other talks here on Quarkus, so I did not explore that, but I am going to explore something else of interest. But Quarkus is a future topic for me. I haven't evaluated that yet. So, for a future talk. But all you need to do really to make a Camel standalone jar is you're just using the Maven assembly plugin, which is just taking all of your dependencies that Camel is already pulling in for you from the components that you've defined in your POM, and you're packaging that together, and then you're going with a main method in order to start up the Camel context. Those main methods, they've actually created some convenience classes to make the main a lot easier. So there's a Camel main method where you can just start it. You can add a configuration bean if you want to register that, and then you just add your routes. And that will start upon that. And then this, you can control C to stop it. It's just like any other Spring Boot application where you're going to start and stop a jar file. So there's some great advantages of just using standalone. You can maximize density. You just need to know Camel. If your team is not a Spring, it doesn't have a lot of Spring knowledge on it, you may not want to introduce another technology to your stack. This way, if you're just using Camel, you just keep using Camel. All right, so Kubernetes. So how many hands were using? I actually saw quite a bit. All right, so for Kubernetes, all of the previous things that I've gone over you could do. It's just some are better than others because Kubernetes has all the advantages of Docker, right? So you have everything containerized, but you also get some of the discovery and scaling through controllers in Kubernetes. So there's operators in Kubernetes that will do this for you, like Istio. So you may not need Hysterex in your applications anymore. I'm going to let the operator do that for me. But with that, you inherit a lot of complexity. It's death by YAML is what you usually hear when you're using Kubernetes, right? So we've gone back to COBOL, spaces matter again. And there's a lot of configuration that goes into it. You also have limited control over what you can do. You're using the opinion of the orchestration tool that you're using. So if you want to do something in a certain way, if it doesn't fit with how Kubernetes works, it's going to be difficult. But Kubernetes also unlocks some really new and cool stuff that they're working on in the Camel ecosystem, and that's called Camel K. And the best way to describe this is it's like Camel, it's like functions, but with Camel. So think Lambda, think things like that. So for that, I've got a few demos that I want to show, but the coolest thing about this, I'm not going to be showing you POMs. I'm not going to be showing you build pipelines. There's no jar to deal with. I'm just going to be looking at code and then pushing that code to a Minikube Kubernetes cluster I have running locally, and it just works. So messaging is a very common use case for Camel. So I'm going to have a consumer and a producer running in a Kubernetes cluster. So let's start that up. So with Camel K, so let's kill these. So right now, I don't want to depend on an internet connection. So what I did is I have a specific version of Karaf that just runs an ActiveMQ distribution. So I have basically a pub sub queue running on my host. So from here, whoops, that's my wrong one. All right, so from here, what I'm going to do is I'm going to let's start so that's my consumer. Is this? No, that's my JMeter. Here, I can just start another one. No big deal. All right. So all of the Camel K, oops, let's start closing some stuff. I got too many tabs. You can tell I'm a big tabs person. When I'm on a web browser, it's just everything's open. So, so when you use Camel K, you're basically just using a camel. Is that big enough? You're basically just running an executable, pointing it, so I can pass in environment variables, just like if I was running a Docker container, and then I point to a script. And in this case, it's a Groovy script. So I'm going to kick that off, and then we'll take a look at the code. All right, not that one yet. So I just started the consumer. Let's make that bigger. So all I have here is I'm importing the ActiveMQ connection factory because I do need a reference to the connection factory to configure it to point to my local host. And then I'm just writing a from route. So this is just Groovy, right? So I'm listening to the ActiveMQ route and just logging the body. Now let's take a look at the producer, just so I can copy my script too. Here on the producer, I'm configuring the same connection. Now, if I was doing this in the cloud, it could be an AWS SQS queue, it could be anything. And on a timer, I'm going to push a new message out that says, hello, Camel K. All right. So I'm running my producer. Okay, my consumer started off and I'm logging. I'm starting it in dev mode. And dev mode gives me access to all the logs, but if I were just to run this in a normal cluster, I could still use my Kubernetes kube control logs and then point to the pod and get the logs off of it. And what this is doing is it's actually building and running the code in the Kubernetes cluster and deploying it. So this is live running in the Minikube instance on my desktop. One of the cool things you can do with the dev flag that I had in there is I can actually make live updates to the code. So we're saying hello Camel K. Let's do hello Devnexus. And once I save it, so that's my listener, but you'll see it actually build and deploy out to the Kubernetes cluster my new message. So it looks like it started up, and in a minute I should probably start getting messages again. So now we're able to do these live updates, so we can do very fast iteration cycles on Camel. When we have big Camel projects and we have to build them, a lot of times the build times take a while. This helps solve some of that problem. And if I want to take a look at different things on the cluster, let me just start up a new one. Like I said, so it just starts with that Camel executable, which is download. Let's say I want to do kube control get pods. So what we'll actually see is we'll see our consumer pod running, our producer pod running, and we've also got these kits running. And these are the things that actually build and do the management of the applications being deployed in Kubernetes. So these stay out there. So as I'm doing my REPL, or it's not really REPL, as I'm making live edits, these containers stand around to rebuild and redeploy these instances. So messaging is cool. But let's say we want to do something a little bit more interesting. Let's say we want to build a REST interface. We can do that as well. And let's say we don't even want to use let's say we don't even want to use any of the REST DSL in Camel. We can do that too. So this here is an open, I want to be big enough so you guys can read it. This is an open API spec, right? So this is JSON. I can point to this and then define a operator or a operation ID called greeting API. So basically this is a route that takes in your name and then it says hello, your name, right? So your basic hello world. It's defined as a spec and it has an operator. I have greeting API. I can then define a Groovy camel route that references greeting API as a direct route. And what's going to happen is Camel K is going to create the REST interface for that, and take the calls, open up a port. It's going to open up a service on the Kubernetes cluster and direct that traffic on port 80 to my direct Camel service. So why don't we go ahead and do that? So here I've got it in dev mode. I'm naming it. I am defining a few dependencies here, which you'd normally do in a POM file, but again, there's no POM file. I'm saying I'm going to use the camel rest dependency so that it has it. I'm going to pull in undertow, and then I'm going to have undertow running on 8080, and then that's going to create the service for me. Yes. So it's going to do all that for me. And based off the API spec, too. So I didn't actually write any interface code. I just did the JSON for the open API spec. Mm-hmm. Yeah, a lot of it's Go. Again, it's Kubernetes work. Now it's running Camel in a Groovy script. Now there are ways to, they are building Quarkus extensions so that you can compile it down to binary. There's a lot of work going on. This is a fairly new space, new community that's working around this. But again, it's a lot of the folks from Red Hat, same folks that are already involved in Camel are doing a lot of this work.
And you can use Java with this too, right? Because
yes, Java, Kotlin, JavaScript, Groovy. I might be missing one other one, but there's different language packs, and that's what drives it. So it says it's updated, so I don't know that means it's running. I have it in dev mode, so it should. Let me just check to see. I wonder if it's because I already had it. So let's do Minikube. Actually, let me find out where this is running first. So let's do the kube control get services. Okay, so here's my cluster IP. So I'm going to do it from inside the cluster because this IP is only known inside the Kubernetes cluster. So we can do curl cult. Greetings, Bob. So I got my hello from Bob. So it has started the service and everything else. Now the cool part is I can change this on the fly. So let's say I also wanted to throw, for example, my last name in. All I have to do is modify this open API spec. Let's add a last name, right? Let's add last name to the URI path, like that. So now we have two path parameters. And then let's modify our from route. So we also print headers. So these come in as headers when they're off the path, and then we'll do last for the last name. So once I save that, again, I should just be reloading. Oh, there it goes. Starting up, we see my new path started. Listener should be there. Where's my Minikube? Yep, here we go. So let's run HTTP 1097. Camel. And then I'll do my last name. Oh, it might help if I put curl on there. So now I'm able to modify my rest route on the fly without having to redeploy. Well, it's redeploying for me, right? So I just modified the spec and added it printing out, and we're done.
So are you able to push
You don't, I mean, so there, you don't package the jar. You would pass a .java file. Does that make sense? So it's really just for scripting. This is for small function type things. You know, even if you're using Lambda, yes, you pass AWS a jar file, right? The idea of this is I'm not adding any of the dependencies, any of the other cruft around it. There are ways, so you saw in the other example where I added camel undertow, I added camel rest to the dependency path. If I need to do that with other Maven dependencies, I can do that. But at the end of the day, this is for small function type things. If I want to do something bigger, it's probably better to go back to like, let's go back to our Docker example with Spring Boot with Camel standalone. We need to do something really big, Karaf, put it in a Docker container, push it out to Kubernetes. But there's a number of things where I'm just trying to get two things to talk to one another in the cloud. I can use Camel K to do this. Now, as this is a fairly new thing, I am not running this at any of my clients yet, but I am keeping a very close eye on it because they're using functions and other things that they could be using this for, and they already have developers that know Camel. So there's a lot of benefit to picking this up if you have a team that already knows Camel. So, all right, so that's actually all I had. So we may have, I think what's 3:10 is the next talk, so we're probably right about at time. But if there are any questions, I can probably take them real quick until the next speaker comes. But thank you very much for your time, and I hope you enjoy the rest of your conference.